Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I bid to our lecturer, T.S. Maslan bin Zainon. We are from Group 4 from Section 1/2. Want to present about our assignment, which is for the subject BA 4803 Flexible Manufacturing System, which entitled Schneider Electric Lion Steel RTU and HMI. So our group members are me, myself, Muhammad IZZUDDIN bin Muhammad IDRUS, and then we have Muhammad BADRUL IQMAL bin Muhammad ITHNIN, and then we have Muhammad AMIRUL HAFIZ bin TUAH, and lastly we have Muhammad HAZWAN bin SABRI. So before we start to our HMI, before presenting about our HMI, I want to talk about what is actually SCADA system. So SCADA system is a short form for supervisory control and data acquisition, or SCADA is a system that aims to monitor and control field devices at your remote sites. SCADA systems are critical as it helps maintain efficiency by collecting and processing real-time data. SCADA is a centralized system that monitors and controls the entire area. This supervisory system gathers data on the process and sends the commands control to the process. The main goal of this supervisory system is to monitor and control equipment in the industrial processes for companies in the public and private sectors. As a matter of fact, in today's world, there are SCADA systems almost everywhere. This includes industrial plants, manufacturing, transportation, oil and gas, power distribution, water control, and etc. So the slide shows us the SCADA functions and the components that make SCADA operations possible. So we have the PC that shows the SCADA programming, and inside the PC we have the HMI, which is the human machine interface. So the connection between the human machine interface and the PLC are data and control, which is signals that sends between the HMI to the PLC. And lastly, the PLC will send the signals to control the equipment, whether it to move or just to turn on and off, or just to act as a teleportation, for example, the conveyor. So next we move on to the SCADA functions. So there are 4 SCADA functions. So the first one is data acquisition, which is the data of SCADA. Data frequently involves some kind of analog to digital conversion. And the next one is network data communication, which is the collected data is transmitted either spontaneously or in response to a request for data to some kind of upstream consolidator or master. And the third one is data presentation, which is when the collected data is processed, organized, and presented for system operators to make appropriate response and control decisions. And lastly, the control, which is the control decisions are warranted and the system supports output. Appropriate commands can be dispatched to affect specific operational or configuration changes. And the last part for my presentation before we move on to my friends is the main components of SCADA. So the first one is obviously the inputs. So what is the inputs? The inputs either digital or analog, and output relays or electrical signals that directly interface with managed elements in the remote sites. That's where the SCADA function starts. And the next part is the RTU, which is the remote telemetry units. Just like PLC, RTUs are small computerized units deployed in the field at specific sites and locations. The next one is obviously the HMI SCADA. which is the human-machine interface software, is a computer master station systems that processes data and allows a human operator to manage and control the system. And the last part is it is the communications network. If control the communications network is what connects. Telemetry and SCADA at your remote sites are warranted and the system supports output. Appropriate commands can be dispatched to affect specific operational or configuration changes. Okay, I pass on to my colleague, Muhammad HAFIZ.
Hi everyone. So my name is Muhammad HAFIZ bin TUAH, and I'm going to continue about the Foxborough RTU product history. Okay, before we continue to go deep about the products, so let me explain first about the Foxborough RTU product history. Okay, first, the product of Foxborough RTU is developed by Leeds and Northrop Australia, and they are divisions of General Signal from 1978. So the Leeds and Northrop was acquired by Divisions General Signal Corporation of Sanford, which is in Connecticut. So the original names of the company was produced about the electrical measuring instrument for laboratory and testing use. So they make an experiments about the electrical measuring for the such as galvanometers, potentiometers, bridge, and laboratory type of equipment of high quality for the electrical. So they are formerly known as the Leeds and Northrop Australia company. So they are developed the Foxborough RTU. So the Foxborough RTU purchased the SCADA divisions, which is collabed with the SCADA divisions of LNA in 1996. They are consist of the borrow from the Leeds and Northrop, and they are own all the Leeds and Northrop SCADA intellectual properties, and they renamed their company to the Foxborough Australia. So basically, they are stay in the Australia. So the next is international installation reference for more than 25 years. They are installed the RTU products for more than 25 years. So the first product is the RTU. So for RTU 50 installation is based from 1997 until present, until now actually. And for the SCADA, which is the SCD 52200 products, is installation based from the 2009 until present, until now around the world. So the Foxborough RTU products is installed about 1,500 units of RTU floor standing on wall mounted at southern region for the first phase. For now, they are all over the world. The RTU has been installed all over the world, including Malaysia. So there are 12 sites at TNB, which is TNB substations, SCS replacement. So in Malaysia, TNB has been used the Foxborough RTU products for the electrical products. Okay, I will go to the first product. Okay, let's move on to the next product. The communication. Okay, this is the first product by the Foxborough RTU. So this is the mediums, which is the communication protocol support, which is it supports the communications tools to give the communication between the substations and the sites, site stations. So it include the DMP3 slave and masters. It use the DMP3 slave and masters, IEC 660X70 slave and submaster, and also the slave 103 slave. It also use the Modbus slave and submaster. It still use the WISP plus slave master and submaster. So this communication protocol is still the old versions of the Foxborough RTU. Okay, for next RTU hardware features. Okay, this is the one part of the RTU station, which is the file chassis. It includes the file chassis and the power supplies. So it has two functions, which is the supports 2 slots, 5 slots, and 10 slots of file chassis, and also it gives a power supplies. The power supplies give a wide range input supplies between the 18 and into the 164 voltage direct currents, and it consists of 100 watt output capacity with an overcurrent and undercurrent protections. RTU system failure alarm LED and contacts, which is such will react such as a relay, and control supply is isolation input, low power distribution terminal, and it also has the power supply LED indicator to make sure it is okay or fail. Okay, I will go on to the next RTU hardware features. So this is the next part of the RTU hardware, and this is the processor. The processor is to process to give the processor to the RTU stations, which is it controls all the communications part. It controls the I/O and input and outputs. It has a 2 serial communication parts. It consists of 16 MB of RAMs, dual 100B base and FL 100 base FX Ethernet ports, which is give the communications to the substations. Alternate networks up to 63 nodes. Total network length up to 5.8 kilometers, maximum of 500 between nodes. So the TMB will use that suitable with their substations for the processor. So the processor use the optical fiber, which is use the multi-mode glass cables and input-output data available to all nodes. Okay. For the next part is the list of I/O modules. Okay, the I/O modules is the inputs modules which is receive the electricals and controls to the substations. It has a 20 channel analog input module, which is 20 analog inputs. It has a resistor feed for current input from plants. Example, as a transducer, it store the power, and it is typically 4 to 20 milliampere fitted with the 100 ohm resistor. And the next is the digital input module. For the digital currents, it has AI for analog input for 4 points, and digital input is 32 points. So the input voltage used is 24 volt and 129 voltage, selected individually per input by jumper setting. It is various configuration selection. In example, for counter binary code and DISO, DISOE. For the next part, I will pass to my friends, BADRUL.
Okay, hi, my name is MOHAMMAD. Okay, I will continue with a list of input-output modules. Go to the digital output modules. We have a 12 independence relay, run or fail LED inductor, relays configuration as on and off individual, trip or close or rise lower pairs, leads or pulse individual, built-in hardware and software monitoring of all control operations, control isolate or enable switch per output module, security control, select before operating, control output duration is configurable. For next part is multi-IO module. Multi-input-output is a combined technology of analog and digital input module and have a 12 digital output module within one module. AI in analog input 6, DI digital input 24, and DO digital output has 4. Okay, next slide is this slide is one of the example Arduino AutoCAD for TMB cabinet for digital input. Okay, we can see there has some AC supply, DC supply, and fiber optic cable. Okay, move on to the next slide. Okay, this is RTU and HDM architecture overview of TMB just now. Okay, we have a type of DF overview is a triple panel RTU transmission network. Okay, this is a single panel for cabinet. Okay, next part is we move on to the it's a function of HMI. Okay, a space where interaction between human and machine occur. The goal is to allow efficient operation and control the machine from human end. Okay, next. For my last part is why HMI is important. Okay, it's for safety, system perspective, response, and value. Okay, next I will pass to Afiq Hazwan.
Okay, Assalamualaikum. My name is Muhammad HAZWAN. Okay, I will resume what is protocol support. Okay, for protocol support, we use the modular TCP, IP, IEC 61850, and IEC 104, and the MP3. The protocol support that used by JMB. Yes. Okay, this one for HMI architecture. This one we master support, we going to R&D and then going to plan or HMI. Next. Okay, this one for example HMI SLD diagram by Tenaga Nasional Berhad. And then this is zoom in bay for display zoom in bay from TMB. Then for the last one, this one for the alarm list by TMB too. Okay. Finish.
Okay,
Thank you.
okay, that's all from us from group BA 1-2, group 4. Okay, thank you.
Thank you. Thank you guys. Thank you, sir.